Hey, hope you're having a good day and a good week so far. I will be back tomorrow. And for us, that means there's one more lesson, which is going over kind of everything. And then we'll have a checkpoint on just Pythagorean Theorem on Friday. It's, again, just a 3-lesson topic right now. So that's what we're going to do, 3 lessons. All right. So today we're going to talk about applications of the Pythagorean Theorem, specifically focusing in on calculating the length of the missing side. So yesterday we focused in on calculating the hypotenuse, which was our C, which is across from the right angle. Today we're going to be focusing on calculating the length of side, which is going to be our A or our B. Just a quick update. So yesterday I posted your exit ticket and the video, and only 6 of you submitted. I calculated this data and grabbed it actually this morning. So this is accurate as of before 10:30 this morning. Only 6 people submitted it. However, all 6 received proficient or advanced. So I put their names on here. So great job, Jordan, Nakaya, Anaf, Mariah, Allison, and Sanila. Thank you for completing your exit ticket. If you did not complete it, you currently have a 0. Okay, let's jump into the lesson. I have attached this PDF to the classwork file that has this video. So feel free to make sure you look through this. The first thing I want to do is really focus in on rounding. Rounding seems to be one of the bigger deals. And it may not feel like a big deal, but it is actually one of the big things that kind of get people stuck or stopped up when we're talking about Pythagorean theorem. Rounding will either make you or break you. In this case, we want to make sure that it only makes you. I'm only going to be going through the examples in this packet, which is just this first page. You have 6 practice problems in the exercises and then a ton in the problem set that's going to be attached. So again, feel free to write these down in your notes so that you can have them. Tomorrow you'll have an actual packet. So first we're going to start by rounding the first one to the 10th place, which is 1 decimal place. So 0.3. We're going to do that straight across. Go ahead, draw this table and fill it in. Okay, you should have 14.1, 71.3, and 79.0. Next, we're going to fill in the hundredths place, which means we're looking for 2 numbers after the decimal. So for the first one, that would be 0.28, simply because the number 6 is 5 or above. The rule is 5 or above, give it a shove. 4 or below, leave it alone. We always look at the number to the right of the place we want. So 6 is to the right of our hundredths place, so we would put 0.28. Go ahead and fill in the next row. Great, so you should have had 14 and 11 hundredths, 71 and 27 hundredths, and 79 and 4 hundredths. Okay, last up is our thousandths row. I'm going to do the first one and give you time for the last. So for the thousandths, we're looking at the 6 and focusing on the place next door, which is the 1. 1 is 4 or below, so we're going to leave the 6 alone. So we should have 0.276. Go ahead and fill in the rest of your chart. Great, you should have had 14.109, 71.268, because 5 is 5 or higher, 5 or above, so we gave the 7 a shove, and 79 and 039. So we had 14 and 109 thousandths, 71 and 268 thousandths, 79 and 39 thousandths. Great. Make sure you have this written down to help you with your rounding. Let's start with our first example. Our first example has two parts. Okay, so same CFS from yesterday. Identify the parts of the triangle, write Pythagorean theorem, substitute, and solve. First off, I'm going to identify the easiest part for me, which is my hypotenuse, because it's always directly across from the right angle. 3 is my hypotenuse, which means it is automatically my C. Then I'm going to identify my legs. This is a leg. This is a leg. One of my legs has to be A and the other B. It doesn't matter which one. This one will be A and this one will be B. Now I'm going to write out the Pythagorean theorem. A squared plus B squared equals C squared. And substitute in. For A, we don't know it yet, so we're going to write A squared. For B, we have 1. And for C, we have 3. Now I'm just going to substitute and solve. Substitution done. Solving. Here we go. Still don't know A squared. 1 to the second power is 1. 3 to the second power is 9. Now, instead of just adding it, I need to solve for A squared first. So I'm going to subtract 1 from each side. My A squared comes down, and I get that 9 minus 1 is 8. The last step is to undo that second power, that exponent. So we're going to take the square root. Now it says to round to the nearest hundredth. That is 2 decimal places. I'm going to move right next door and put that A equals the square root of 8. Now, I don't know what that is off the top of my head, so I'm going to put it into my calculator. Remember, to do the square root, you're going to click second and then x squared in your calculator. Now, when I put that in my calculator, I get 2.8284271247462, and so on. I'm going to round that. A is about 2.82 units long. The squiggly equal sign is the about sign, so please make sure that if you're rounding, you're using that sign. Let's look at another. First, find the hypotenuse. Next, label your legs. After you've labeled your legs and hypotenuse, write the Pythagorean theorem. A squared plus B squared equals C squared. And then we're going to substitute and solve. A is 11. We don't know B. And C is 14. 11 squared is 121. 14 squared is 196. We're going to start to memorize some of these perfect squares if you haven't already. Now I'm going to solve for B squared first, minus 121 on both sides because I want B squared by itself. That comes down. And we get that b squared equals 75. Now that's not the final answer because that's b squared, not b. So we take the square root of both sides. B equals the square root of 75, but we want to round this to the nearest hundredths place. So putting that into my calculator, B is about, to the nearest hundredth, so 2 decimal places, 8 and 66 hundredths. Boxing my answer. The difference between finding the hypotenuse and the leg is just if you're adding or subtracting. So you're either adding them straight across or you have to subtract first. Our last question asks us to draw a triangle first. So let's look at that. It says, given a right triangle. I'm going to pause there and draw a right triangle. Great. Right triangle drawn. Right angle put in the corner. It says with a hypotenuse, that's our C, with a length of 13 units. That's across from here. Our C is our hypotenuse. And it's 13 units. And a leg of 5 units. I'm going to pick this leg over here to be 5. I'm going to call it A. Determine the length of the other leg. Okay, let's do it. Same thing as before. Remember, you can always pause this video to go back and see what you're missing. First, Pythagorean Theorem. Then substitute. Leg A is 5. We don't know leg B. And C is 13. Now I'm going to solve. 5 to the second power is 25. 13 to the second power is 169. I'm going to subtract 25 from both sides to get b squared by itself. B squared is 144. This is where some people would stop, but we don't have b. So we take the square root of both sides. And we get that b equals 12. And this is a word problem, so we need to write our answer in words. So the length of the other leg is 12 units long. Great. If you've got that, great. If not, take some time to try to understand how I did these examples. You can continue to practice on the next pages. Again, you'll have to write these in your notes. There are many practice options. Otherwise, if you're ready for your exit ticket, go ahead and make sure you get your exit ticket done, showing all work. I will see you tomorrow. Have a great rest of your day and good luck.